This submission is a comprehensive collection of technical guides and product documentation exploring the mechanics, standards, and practical applications of Power over Ethernet, or PoE. It is incredibly well researched. But right out of the gate, your material's fluctuating technical depth creates a jarring experience that risks alienating both beginners and advanced engineers.
Yeah, the content swings wildly across the spectrum of technical proficiency without, any warning to the reader.
Right.
When you're writing documentation that spans both theory and application, establishing a baseline expectation it's critical. In one paragraph, you're using highly simplified analogies like comparing PoE to a smart train track that carries both people and food.
Yes, I noticed that whiplash immediately.
You really do. You go from the train track metaphor straight into detailing how PoE is a Class 2 circuit delivering 44 to 57 volts DC
Exactly.
and requiring a specific resistance between 23.75 kiloohms and 26.25 kiloohms during the discovery phase.
Yeah, it's intense. And this lack of a consistent baseline means a layman will get completely lost in the voltage specs.
While an IT professional will feel patronized by the train analogies.
Precisely. There's no steady ground for the reader to stand on, which, can severely erode trust in the text.
So how do we fix that?
Well, you need to stratify the content by establishing a layered information architecture, allowing readers to self-select their preferred depth of technical engagement.
Okay, that makes sense.
You have all the right information here. It's all sitting on the same flat plane. We need to introduce a vertical dimension to the reading experience.
I can see what you're going for here, but how exactly should the author execute this layered architecture in a practical sense?
Sure.
I mean, we're talking about written documentation. So how do they physically separate this out on the page?
You want to utilize a progressive disclosure format.
Okay.
This is a concept from user interface design, but it applies perfectly to technical writing. First, you place the accessible analogies, like that train track metaphor we talked about, in introductory summary boxes at the very top of each section.
Oh, so it gives the beginner a quick conceptual anchor before they, wade into the denser text.
Exactly. Then, you visually separate the dense, deep dive metrics into expandable panels or clearly delineated sidebars.
Like the Mode A versus Mode B pinout tables?
Yes, or the intricate 5-event classification process for the IEEE 802.3b standard. Keep the core, default narrative strictly focused on practical implementation.
Letting the reader decide when to click into the raw electrical engineering data.
Right. They can pause to read it or just keep scrolling.
I have to push back a little on this approach, though.
Oh?
Yeah, if we hide all the advanced technical details inside expandable panels and sidebars, doesn't that disrupt the natural reading experience for the engineer who actually came for those specs? I worry that over-segmenting the content might make the guide feel fragmented, almost like a disjointed wiki rather than a cohesive guide.
Is there a risk that it feels disjointed? Maybe, if it's designed without intent.
Right.
But think about the psychological shift happening in the reader's mind when those deep dives appear in line.
Okay.
When you're explaining that Mode A injects power simultaneously with data over pins 1, 2, 3, and 6, while Mode B uses the spare pins 4, 5, 7, and 8, you are stepping completely away from the how to use this technology narrative.
And entering the how this technology was historically engineered narrative.
Exactly. Those are two fundamentally different reading mindsets.
That's a really fair point. It's a fundamental shift in the type of information being consumed.
Yeah.
Let me propose an analogy here. Think of a well-designed museum exhibit.
Oh, I like that.
The main walkway offers a broad, accessible narrative that anyone can follow. It tells the chronological story of the subject, and it keeps the foot traffic moving.
Right, the general tour.
But off that main walkway, there are side rooms available for the historians and the researchers who want to examine the intricate artifacts and raw data up close.
Yes.
So the main path isn't broken, it's augmented.
That is a brilliant way to frame it. Building on that museum analogy, this structure empowers rather than restricts the reader.
Exactly.
The senior network architect can skim the summary plaque on the main walkway and step right into the side room to study the 5-event classification process.
Because they want to know exactly how a switch sends out 3 additional voltage pulses.
Right, to determine if a device requires up to 90 watts of Class 8 power. Meanwhile, the beginner stays firmly on the main path.
Learning how to safely plug in their new IP camera without feeling overwhelmed.
Yeah, without drowning in voltage thresholds and classification pulses.
It honors both audiences simultaneously, without forcing one to endure the pacing of the other.
Precisely.
And pacing is really the operative word here, which brings us to the next major area for improvement. The integration of complex mechanical processes with product catalog listings disrupts the logical progression of the underlying educational narrative.
It really does. The submission contains deeply fascinating mechanical explanations. You, as the author, clearly have a profound understanding of the 3-stage POE negotiation process.
Discovery, classification, operation.
Yes. However, this compelling educational arc is frequently interrupted by dry lists of product SKUs and marketing boilerplate.
Oh yeah, the inventory lists.
Right. Dropping extensive inventory lists of Omnitron media converters or TP-Link switches right in the middle of a theoretical breakdown halts the reader's momentum completely.
It breaks the causal chain of learning.
Completely.
I felt that collision as a reader too. You're deeply invested in reading about how the power sourcing equipment sends a low-voltage pulse to measure resistance on the line.
Yeah.
And suddenly, mid-thought, you're staring at a bulleted list of 24-port gigabit switches. It rips you right out of the concept.
To fix this, you need to restructure the material to fully resolve the educational and theoretical concepts first.
Let the lesson finish.
Exactly. Let the lesson finish. Then, introduce your specific commercial solutions as applied, real-world case studies rather than simple inventory lists.
You need to bridge the gap between theory and commerce.
By making the product the logical conclusion of the lesson.
I want to make sure the listener knows exactly how to implement this. Walk us through a concrete example of how this restructuring looks in practice.
Sure.
How do we take that negotiation handshake and fix the product integration?
Okay, so first, group the entire IEEE 802.3 negotiation handshake into one uninterrupted, cohesive narrative.
So the reader fully grasps the why and how of the technology.
Right. You explain how the discovery phase measures resistance to ensure it's safe to send power, and then how the classification phase determines exactly how much power is needed.
You build the tension of how delicate this process is.
Exactly. Once that theory is firmly established, you use specific products to demonstrate these concepts in action.
Give me an example?
Well, instead of just listing the TP-Link TL-SL1311MP switch in a vacuum with its basic port specs, frame it as a case study.
A case study for what?
For overcoming failed handshakes using its POE auto recovery feature.
I see. So you introduce the hardware as the specific hero that solves the theoretical problem you just spent the last 3 paragraphs explaining.
Furthermore, when you bring up the Fluke Network's Link IQ tester, don't just drop a hyperlink in a price tag.
Right, that feels too much like an ad.
Describe how that specific piece of hardware physically validates the software classification stages you just taught the reader about.
Oh, that's smart. Purpose.
Sure.
This is meant to drive sales or at least product consideration. Is there a risk that delaying product mentions until after a long, deep theoretical explanation might hurt conversion rates?
It's a common concern.
If the ultimate business goal is to sell these specific switches and injectors, burying the product links below the educational text seems like it could be, counterproductive to the bottom line.
It is a very common concern in technical copywriting, but could the evidence actually support a different conclusion here?
What do you mean?
Contextualizing products within an educational journey actually builds much stronger buyer trust. When a reader truly understands the exact nature of a complex problem, like why a failed handshake prevents their expensive security camera from booting up, a product presented as the specific, engineered solution to that problem becomes highly desirable.
Ah, they aren't looking at an ad anymore. They're looking at a rescue ring.
Exactly.
Because they aren't just buying a metal box with Ethernet ports on it. They're buying the POE auto recovery feature because they now deeply understand the pain and frustration of a dropped maintained power signature, or MPS.
Yes, the education creates the demand for the specific feature.
That's fascinating.
That is the exact psychology you want to tap into. During the operation phase, you explain that the powered device has to generate an MPS signal to tell the switch to keep sending power.
And if that signal drops, the switch cuts the power for safety.
Right. By explaining that mechanism clearly first, the TP-Link switch isn't just a random skew you're trying to push. It's the exact tool required to manage that specific failure state in a remote deployment where you can't manually unplug the camera.
You transform an inventory list into a compelling catalog of solutions.
Exactly.
That is a very powerful way to align educational content with commercial goals. It brings a lot of value to the reader while still serving the business purpose.
Win-win.
So once we have them buying the right product for the right reason, we have to prepare them for what happens when they actually plug it in.
Naturally.
Let's look closely at the section discussing the real-world deployment. While the theoretical capabilities of POE are exhaustively documented, the practical limitations and real-world edge cases require significantly more focused attention.
This is a critical area for improvement, especially for a guide aiming to be a definitive resource.
Yeah.
The text excels at explaining the theoretical standards like POE, POE+, and POE++, and it details the mathematical voltage drops over distance, such as the theoretical possibility of using extenders to reach 500 meters.
But it glosses over the actual friction points.
Yes, the hazards of mixed environment deployments.
It does mention that passive POE can burn out non-POE devices because the power is always on.
Right.
And it briefly touches on the existence of dual signature versus single signature power devices. But it fails to explore the practical consequences and troubleshooting steps for these critical failure points.
Exactly.
As a reader, I'm told the hazard exists, but I'm not told how to navigate it, diagnose it, or fix it.
The suggestion here is to dedicate a focus section specifically titled something like Deployment Pitfalls and Troubleshooting that grounds all of these theoretical specifications in practical reality.
Okay.
You need to shift the tone from a theoretical textbook to a field technician's survival guide.
I love a good troubleshooting section because it is inherently high stakes and engaging. What are the concrete examples of what the author needs to build out in this section?
Well, first, create a vivid troubleshooting scenario highlighting the specific danger of plugging a standard, non-POE device, like a laptop, into a 24-volt passive mode B injector.
Okay.
You have the technical knowledge, but you need to write out exactly what happens at the hardware level when that always-on power hits the wrong pins, rather than just giving a one-line warning.
Let's expand on how the author should frame that. They already know the mechanics, but how do they write it to maximize the impact for the reader?
You frame it around the missing discovery phase.
Oh, interesting.
You remind the reader that in standard active POE, the switch sends a tiny, harmless pulse to look for a specific 25 kiloohm signature resistance. And if it doesn't find it, it refuses to send power.
Right. Then you contrast that with passive POE, which doesn't ask questions and just blasts 24 volts continuously over the cable.
Oh, wow.
You write out the scenario. If a technician accidentally plugs that active cable into the standard data transformers inside a non-POE laptop's network card, the voltage has nowhere to go but into the motherboard.
Physically destroying the component.
Yes. By explaining the mechanism of destruction, you ensure the reader respects the warning.
That is exactly the kind of why and how the reader needs. A warning label is easily ignored, but an explanation of the underlying failure mechanism creates a lasting memory.
Exactly.
What else should go in this dedicated pitfall section?
You really need to unpack that dual signature negotiation failure. Right now, it's just a passing mention.
Right.
Use the specific example of a PTZ, pan-tilt zoom camera, that requires one power level for its optical lens and another separate power draw for its physical motors.
Okay.
Walk the reader through what it looks like on the ground when a single signature switch fails to negotiate with this dual signature camera, and provide the exact steps to resolve it.
Because from the reader's perspective, a single signature switch looks at the cable and allocates one power envelope.
Yes,
But the PTZ camera is essentially two devices sharing one housing. The camera needs 15 watts, and the motors need 30 watts on a different set of pins.
Exactly. And if the author doesn't explain this, the reader is going to be incredibly frustrated when they deploy the hardware.
Definitely.
As a diagnostic symptom. Explain that the camera might power up its lens perfectly fine, giving the illusion of success.
But the moment the operator tries to pan or tilt,
The entire unit browns out and reboots because the switch denies the sudden extra power request.
oh, that would be maddening in the field.
Right. The reader needs to know how to diagnose that specific behavior, recognize it as a signature mismatch, and know which managed switch settings to adjust to fix it.
That's incredibly actionable.
Finally, you need to deeply contextualize the fast cabling distance chart you included.
Yes, the voltage drop chart. The material includes this large reference table showing that a 48-volt input leaves 15.82 watts at 200 meters,
Yeah,
while a 55-volt input leaves 22.22 watts. It is purely raw data right now.
instead of just displaying that mathematical output as an engineer's reference table, you need to frame this as a practical troubleshooting guide.
For when an IP camera continuously reboots due to voltage drop over long cable runs?
Precisely. Looking at that raw data without a troubleshooting narrative leaves the reader completely stranded in the field.
It's like handing someone a topographic map of a jungle without marking where the quicksand is located.
That is a perfect analogy.
The map is technically accurate, the elevations are correct, but it's practically hazardous because it doesn't tell you how to navigate the terrain safely.
Right. The reader doesn't just need to know the math. They need to know what the math looks like when it breaks their equipment.
That makes a lot of sense.
You need to explain why distance is the enemy of low-voltage DC power in a way that a field tech can actually use.
Okay,
Explain that as the Ethernet cable gets longer, the natural resistance of the copper wire increases.
and that resistance consumes energy as heat.
Exactly, causing the voltage to drop by the time it reaches the camera at the edge of the property.
And because power equals voltage times current, if the voltage drops, the camera's internal regulator tries to pull more current to compensate,
Yes, and that extra current generates more heat.
which causes more resistance in the copper.
Exactly. And eventually the power delivery falls below the camera's minimum operating threshold, causing a reboot loop.
Wow, by walking the reader through that cascading failure, the chart suddenly becomes an indispensable tool.
By framing the 55-volt injector not just as a piece of hardware in a table, but as the physical remedy to push enough voltage through the resistance of a 200-meter cable, you turn a dry specification chart into a highly valuable field manual.
You're teaching the reader how to anticipate failure and engineer around it, which establishes you as an absolute authority on the subject.
Exactly.
This has been a fantastic deep dive into the mechanics of technical writing and documentation structure. Let's quickly recap the 3 core takeaways for the author to focus on in their next draft.
Let's do it.
First, stratifying the technical depth to serve different audiences without causing whiplash.
Right.
Second, separating the educational narrative from the product catalog listings to preserve the learning momentum.
Yep.
And third, expanding heavily on real-world troubleshooting and edge cases to transform raw data into practical survival guides.
In terms of immediate actionable steps, the author should start by implementing progressive disclosure UI elements, like summary boxes and expandable sidebars for those dense electrical specs.
Then, they need to rewrite their product mentions, reframing them as applied case studies that solve the theoretical problems just discussed.
And lastly, they should build out a dedicated pitfall section, focusing intensely on the mechanics of passive POE burnouts, dual signature negotiation failures, and voltage drop reboot loops.
We warmly invite you to implement these structural and narrative changes and submit your revised work back into the critique for another review. We would absolutely love to see how this material evolves.
We really would.
Because at the end of the day, merging the data tracks with the power grid is an incredible feat of engineering. But without the right narrative guardrails in place, your reader is just waiting for a collision. Keep building those guardrails, keep challenging yourself to improve the clarity of your work, and we will catch you next time.